Hi, so this is section 9.1, part 2, video part 2. Okay, we had just been talking about that, the pretzel example, and what we found out was that the z-score was negative 2.56, and we had set up a precise criterion for deciding whether or not to reject the null hypothesis. And it was that we would, if X bar is not within 2 standard deviations of 454 grams, then we would agree that we have evidence against the null hypothesis. So what we got when I calculated the z-score of minus 2.56, we see that the sample mean is more than 2 standard deviations away from the null hypothesis mean of 454 grams. And so that gives us enough evidence to reject the null hypothesis. Okay. So this is an interesting, it's an interesting question, right? We're asking a question about something we can never see. Is the mean 454 grams? Well, unless we can actually produce all of the pretzel bags ever and then weigh them, that could be produced by the machine under the certain condition, and then weigh them all, we will really never know if that machine really needs calibration. We just have evidence based on 25 bags of pretzels. And there is inherent variability in the system, right? There is variability in the system measured by sigma of 78, right? And sigma sub x bar of 1.56, 78 over the square root of 25. Okay, so right there we know that there are sometimes things are not going to be in the center of the distribution than in a normal distribution, even though things happen 95.44% of the time. The normal curve is between minus 2 and 2. There's that other almost 5% of the time, right, where we do see somewhat unusual observations. So the reality is we could be making a mistake. So what kind of errors can we make, or what kind of correct decisions can we make? So we have a little table here in the notes, and it really breaks the world down very simply. Either the null hypothesis is true or the null hypothesis is false. That's the state of the world. That is the state of the machine. You went into work, right? One of those two things must be true. And you get to make two decisions. You get to not reject the null hypothesis that the machine is calibrated, or you get to reject the null hypothesis and take the machine down and recalibrate it. So we have in this state of the world, so if the state of the world is that the null hypothesis is true, then if we knew that, we would know that the correct decision would be, if we did not reject the null hypothesis, that is a correct decision. We didn't take the coffee break and recalibrate, because that was correct, because in fact mu was equal to 454 grams. If, on the other hand, we rejected the null hypothesis, as we did at the whiteboard a moment ago, then we are making an error. So the error that we make here is that we have rejected the null hypothesis when in fact it is true, and we will call that a type 1 error, and we will keep our eyes on it. Okay, it's kind of a probability that we will use throughout the throughout hypothesis testing. Okay, the probability of the type 1 error. Okay, now suppose that the state of the world is different. Suppose that in fact the pretzel machine is not working correctly. All right, then we have we also have a correct decision. And the correct decision would be to reject the null hypothesis, because the state of the world is that H naught is false. That would be the correct decision. That would be, okay, the pretzels are, the machine isn't working that well, we need to recalibrate it. And then, but we could also, if in fact the machine is not working correctly, it's also possible that we get an X bar that's close to mu naught, and that we decide the decision is to do not reject the null hypothesis, and that would be another kind of error. We will call this a type 2 error. Type 2 errors occur when the null hypothesis is not true and we did not reject the null hypothesis. Okay, so here are our error types. Error type 1, rejecting the null hypothesis when in fact it is false. And type 2 is rejecting the null hypothesis, not rejecting the null hypothesis, excuse me, stepping back. Type 1 error, rejecting the null hypothesis when in fact the null hypothesis is true. And type 2 error, not rejecting the null hypothesis when in fact it is false. Okay, so 2 different kinds of errors and 2 correct decisions. So we kind of just went over this a little bit. A type 1 error for the pretzel example is that we calibrated, we rejected the null hypothesis, and we calibrated when in fact the machine was actually already calibrated. Well, you might say, if it was already calibrated, why would you reject the null hypothesis? Because maybe we got like a fluky sample of size 25, something that isn't as common, and sometimes that does happen. Okay, type 2 error for the pretzel machine is that it is not calibrated and you failed to reject the null hypothesis, you failed to recalibrate it, right? And there are 2 possible correct decisions coming back here. One, when it's calibrated and you did not take it down. One, when it's not calibrated and you did take it down. Okay, so we're going to use alpha, and you've seen this alpha before, to denote the probability of a type 1 error. So it's the probability of rejecting the null hypothesis when in fact it is true. And in our work in previous chapters, we've been working with notation Z sub alpha, and that's the alpha that we've been waiting for. So alpha is the probability of that type 1 error. We want it to be small. Okay, and alpha then, a level of significance, alpha, is the probability of making a type 1 error given that the null hypothesis is true. And the alpha is going to be like a tolerance for how much error you can have in your analysis. And possible conclusions from our hypothesis test, right? So we have 2 possible outcomes, and then we need to be able to conclude in each case. So let's look at the situation what we had on the whiteboard a moment ago. And that was that we decided to reject the null hypothesis. And what we could say there then is, if the null hypothesis is rejected, we conclude that the data provides sufficient evidence to support the alternative hypothesis, okay? If we fail to reject the null hypothesis, then we conclude that the null hypothesis is not rejected. If the null hypothesis is not rejected, we conclude that the data do not provide sufficient evidence to support the alternative hypothesis. A quick note is that both of these statements are about whether or not we support the alternative hypothesis. We are really testing to determine whether we can support the alternative. We never really state that the data supports the null. That's a little complicated, but once we start doing problems, you know, it will, I think, get clearer how to work with these possible conclusions for the hypothesis test. All right, see you in the next video.